Hello, my name is DJ Pantone. Today I'll be talking about problem 49. Problem 49 is the one in which you're given a charged arc and you want to find the electric field at the origin. So we can say that the arc is r distance away from the origin at all places along this arc, and that theta initial is the angle between x and r. So on this arc we know that there's a small sliver of charge that we're going to call dq. Now dq is equal to lambda r d theta. And we know that the normal electric field equation says E equals kq over r, or over distance squared. In this case, r will be our distance no matter where you are along the arc, and dq is our sliver of charge, so we can say dE is the small electric field coming from that small sliver of charge. So we're left with dE equals k dq over r squared. Now we go ahead and we replace dq with lambda r d theta, and you're left with dE equals k lambda r d theta over r squared. Now if you come back to my drawing, you can see that the sliver has an x component and a y component to its E field. So the x component will be pushing this way or pulling that way depending on if the arc is positively or negatively charged. However, its EY component will be pointing downwards. But if you mirror that on this side, the exact same angle will have one coming this way and will be pushing upwards. And so these two will cancel each other out, leaving you with just an EX component for the entire arc. So I went over here and said that EY equals 0 due to symmetry. So all you're left to worry about is the EX component. So we say DEX equals k lambda r d theta divided by r squared times the cosine of theta. I simplified it and took r and divided it by r squared, where you just get an r on the bottom. So you're left with DEX equals k lambda d theta divided by r times cosine theta. Next, you can take the integral now, and you can pull out the constants, which will be k, lambda, and r, and just left with the simple integral of the integral from negative theta initial to theta initial of cosine theta times d theta. And you get those limits of the integration from here, where this is your negative theta initial and this is your positive theta initial, the limits. So you take this and you go ahead and integrate, and it turns into sine, cosine turns into sine, and you are left with sine theta initial minus sine negative theta initial. Well, this double negative will make it a positive, leaving you with 2 sine theta initial. So you are left with k lambda over r times 2 sine theta initial equals E. And so that is where you get your answer of E equals 2k theta divided by r sine theta initial I hat. The I hat comes from back up here, depending on if your charged rod is pushing away or pulling towards at that E field, depending on if it's positively or negatively charged. Thank you for listening, and good luck.